Okay, good morning everyone. I'm going to explain to you again just a sort of supplemental to your learning for like a revision. This is about work and energy. So for example, you have here a car of a mass of 1000 kilograms. Okay. So this descends, meaning going down from a hill, as a slope of, in terms of sine, this is theta, for example. Sine is, okay, there's 1 opposite and then 6 hypotenuse. If we do ratio proportion, this is like, what would be h? It should be 5. So we have h over, let's say 30, and then 1 is to 6. You can have h is equal to 30 divided 6 or 5. In other words, this is equal to 5. Now the question is to compute for the average braking force. What would be the force here for the braking? Okay, that is required to bring the car to 18 kph. So from 72 here, from 72 kph with the brake, and of course there's also friction, which is equal to 200 Newton. This will bring down the car to 18 kph. Now let us convert 72 kph will become like 20 meter per second. Just divide this one by 3.6. Okay, also here divide 3.6, that becomes 5 meter per second. Okay, mass is 1000 kilogram. Now the question is to compute for average braking force using the energy method. Energy method is the summation of the energies at point A is equal to point B. Actually, it's the law of conservation of energy. So what are the energies in the point A? At point A, you have, of course, there is potential energy. Why? As long as there is height, there's potential energy. Formula is m, g, and h. M, this is 1000 kilogram. Gravitational acceleration, which is meter per second squared, and then you have height of 5 meters. This will give you joules. Okay. Consider that this should be your units. Kilogram and meter per second squared will give you Newton, and then you have meter. Joules is equal also to Newton meter. And then kinetic energy, because there is initial velocity, okay, which is 20 meter per second, you can get the value of kinetic energy. The total energy at point A is 294,050 joules. So now, how about the total energy at point B? So here at point B, you have your potential energy. There's no height. There's no height here, so that becomes the 0. And then the velocity decreases to 5 meter per second. This is mass. Then you got this one. Okay, so this is the total energy at B. Now we deduct the energy at A and then B. This will be the net energy or the loss of energy. Okay, now this loss of energy is just equal to the work done. What is the work done? Braking force multiplied by its distance. Okay, now that work is equal to force times distance. Braking force and then distance, which is 30. Frictional force, which is equal to, what's that? 200. Okay, and then 30. So if you are going to do the mathematics, this will give you this one. Okay, but just to show you, this is just FB, and then 30 is equal to 236,550 minus this one. Okay, frictional force is 200. Okay, 230. Okay, divide both sides by 30. Okay, in other words, you have 7,685 Newton or 7.685 kilonewton. Okay, so that's all, and thank you.